In this chapter section, we will discuss how to name hydrocarbons. We will start with naming of alkanes. And we are going to describe the number of carbons atoms in the hydrocarbon by using the prefix. And we are going to describe the attached group or the substituent group with the alkyl group. Okay, so here are the name of the alkyl groups and these are the structure. So we are going to use these two tables to help us name hydrocarbon. Let's start with step 1. Step 1, we are going to consider molecule on the left first. Before you name the hydrocarbon alkane, you first will need to find the longest continuous carbon chain. For example, in this case, if you count the number of carbon, you will see that 1, 2, 3, 4, 5 have 5 carbon total. Doesn't matter which way you count, 1, 2, 3, 4, 5. The longest chain of these hydrocarbons still contain 5 carbons. And it doesn't matter whether you are using the long chain as the red labeling or the long chain as the blue labeling, because if you think about the attachment, these two long chain hydrocarbon would contain the same type of attachment. For example, if we consider the red labels as the long chain, the substituent group or the attached group is CH2CH3. If you consider the blue labels as the long chain, you see that the attachment is still going to be the same group, CH2CH3. Therefore, the name in this molecule, either system that you have, is going to result in the same name. However, if you consider molecule on the right, you will see that clearly the longest chain would be the one that highlight in yellow, which contain 1, 2, 3, 4, 5, 6, 7, 8 carbon in the longest chain. But if you count from here to here, you have only 1, 2, 3, 4, 5, 6, which is less than 8. If you count from here to here, you will have 1, 2, 3, 4, 5, 6, 7, which is less than 8. Therefore, the longest chain for the second molecule would be the one highlighted in yellow. Now, after you find the continuous carbon chain, then the next step is to name the substituent group or the attached group to the long continuous carbon chain. For example, in this case, the carbon group, the attachment group that attached to this longest chain is CH2CH3. If you're looking at the alkyl group, right, which is the substituent group here, you will see that CH2 and CH2CH3 matching with the name ethyl. Okay, so that would be, this group would be called ethyl. Ethyl group describe the number of carbon, 2 of them, similar to what is written here as the prefix, right? So if the molecule or the substituent group contain 1 carbon, that would be meth, right? So if it's contain 2, that would be eth, 3 would be prop, 4 would be bute, 5 would be pent, 6 would be hex, 7 would be hept, 8 would be oct, 9 would be non, 10 would be dec. Therefore, if you want to put this as an alkyl group, you are going to end in with -il. Therefore, if you have 1 carbon in the molecule, it would be methyl, right? So if it's 2 carbon, would be ethyl, and so on. Okay, so now let's take a look at the second molecule on the right here. So same thing here, the substituent group, the first one contains CH3, which contain only 1 carbon. Therefore, it's going to be methyl, right? So this would be a methyl. This is also a methyl group. And this contain 2 carbon, that would be ethyl. Okay, so which is matching with these two structure. The next step is to number the base chain and assign number to each substituent group. You are going to begin with the end closest to the branch, right? So this is the branch. So we're going to start with the end closest to branch here. So 1, 2, 3. Therefore, we're going to label this as 1, 2, 3, 4, 5. However, if the 2 substituents occur at equal distances from each end, then you will need to go with the next substituent to determine from which end to start the numbering. For example, this one, if you look at this methyl group right here, these 2 methyl group, if you start from this end, it would be 1, 2. If you start from this end, it would be 1, 2. They are at equal distance. Therefore, you will need to go with the next substituent group, which is, if you go from here 1, 2, 3, 4, 5, this is going to put this carbon number 5. But if you start from here 1, 2, 3, 4, is going to put this carbon as number 4, we are going to go with the lower number. Therefore, we are going to number the long chain carbon from this side to this side because it's giving the second substituent group at the lower number. Then you are going to name the molecule by using this format here, which is the number of long chain carbon that the substituent is located on, the substituent name, and the base name. Okay, so for example, in this case, we already say that this substituent is on carbon number 3. Therefore, you are going to report 3 separate by dash. And this substituent group is called ethyl. So we're going to call that ethyl, right? Followed by the name of the prefix of the long chain carbon. How do we know what is a prefix name? That's when we need to count the number of carbons. So there are a total of 1, 2, 3, 4, 5. So 5, the prefix for 5 carbon would be pent. And then because this molecule is all single bond, this is an alkane. Therefore, you are going to ending with ane. Okay, so that means any molecule that belongs to an alkane group, you are going to ending with ane. Again, to summarize this, you will need to report the location of the attachment group and followed by the name of the attachment and followed by the name of the long chain ending with ane for an alkane. Now let's take a look at the other molecule that we considered earlier. We are going to do the same thing here, but in this case, you have several attachments. Therefore, you will need to go by alphabetically for the name of the substituent. For example, in this case, you have methyl group, 2 of them, and you have ethyl group. E come before M, right? Therefore, you are going to report the location of the ethyl group first. So you are going to do 4 dash ethyl. And because we have 2 methyl group in a different location, so you are going to do separate by the dash and then do the position of the first methyl group, which is 2, separate by the comma, followed by the next location, which is 7. So report 7 dash. And because we have 2 methyl, the prefix for 2 would be di. Therefore, you are going to use di and then describe by methyl because you have 2 of the methyl. And then you have 8 carbon. The prefix for 8 carbon is oct. And because this is an alkane, so we ending with ane. So it would be octane. So the prefix di-tri-tetra, right? Before the substituent would not be counted toward the alphabetically order. Now let's take a look at example 1. Okay, so example 1, first we are going to do the first step, right? Find the longest chain hydrocarbon. So we have 1, 2, 3, 4, 5, 6. Clearly that would be the longest, right? Because if you count here 1, 2, 3, 4, that's only 4. If you count from this side to this side, it would be only 1, 2, 3, 4, 5. So the longest would have 6 carbons. Therefore, this would be the longest chain. Now, where do we put the number 1? This end or this end? That's when we will need to look at the attachment. The attachment, the closest one, is coming from this end. Therefore, we are going to label this as 1, 2, 3, 4, 5, 6 because it's better than going from here, right? If you're going from here, it's 1, 2, 3, 4, 5, 4, right? It's putting the attachment group in carbon number 4, which has higher number than number 3. Therefore, I'm gonna go with this longest chain. Okay, so the next thing is looking at the substituent group. So this one is CH3, 1 carbon. Therefore, this would be in methyl. Okay, the prefix for 6 carbon, the prefix for that would be hex. Okay, so therefore the name of this, we are going to report the location of the attachment group first, which is 3 dash followed by methyl and followed by the longest chain, which is 6. So it would be hex, and this is hydrocarbon alkane. So it's gonna ending with ane. So it would be 3 methyl hexane. Okay, so let's do the second one. Okay, so the second one, let's find the longest chain again. So 1, 2, 3, 4, 5. Should I stop here? Well, it's attached to here. So this would be the longest, right? So 1, 2, 3, 4, 5, 6. That would give you the longest. Therefore, the longest chain doesn't have to be a straight line like that you observe, right? It can go up or down, whatever, as long as it's the longest continuous carbon atoms within the chain. That would be your longest chain. So in this case, which way do I need to count as 1? 1, 2, 3, 4, 5, 6 this way, or 1, 2, 3, 4, 5, 6 this way? The answer is we are going to count from left to right in this case, because it's going to put the first attachment group at the lowest number of carbon. Okay, so therefore in this case would be 1, 2, 3, 4, 5, 6. Again, because it's going to put the first attachment group on the lowest position of the carbon. But if you come from this way, right, if you counting from this way, you will see that the first attachment group will be on carbon number 3, which has higher number than this carbon number 2. Okay, so therefore in this case, I'm gonna go ahead, circle the attachment. Again, the attachment CH3 is the methyl group. Therefore in this case, the name of this, since we have the same type of methyl group, you can report the two different locations, which is at 2 and 4. And because we have two methyl group, that would be dimethyl, right? Because di refer to two methyl group. And we have 6 carbon again, so it would be it would be hexane. Okay, so again, the reason why the hexane, because this is an alkane. Okay, so now let's take a look at the next example. So now, next example, let's do the same thing. Let's find the longest hydrocarbon. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. If you do it this way, 1, 2, 3, 4, 5, 6, 7, that's only 7. 1, 2, 3, 4, 5, 6, that's only 6. 1, 2, 3, 4, 5, that's only 5. Therefore, the longest one would be this continuous longest chain right here. Should I count this as 1 or should I count this as 1? That's when you will need to look at the attached group, right? So the first attached group is start from this side of the end. So therefore, we are going to count this carbon right here as number 1, because it's going to put the first attachment group to be on the lowest number of carbon. So we go from there. So 1, 2, 3, 4, 5, 6, 7, 8. Okay, so, and again, we are going to circle each group, right? So these two are methyl. So we have 2 methyl here. And this group that stick out from carbon number 5. Okay, so this group right here contain 2 carbon. The prefix for that would be eth. And then this is the alkyl group, so it would be ethyl. Okay, so we have 2 groups here. Therefore, the name of these between M and E, alphabetically E come first before M. Therefore, the name of ethyl will come from, would be coming before the methyl group. Okay, so therefore it would be, the location of ethyl would be 5, followed by ethyl. Okay, followed by the location of methyl group, which is 2, 4 dash. And because we have 2 methyl, so that would be dimethyl. Okay, 8 carbon, that would be oct. Okay, and then because it's an alkane, so it's gonna follow with the ending of ane, so it would be octane. Next, we will take a look at naming of alkenes and alkyne. We are going to use the same approach of how to name an alkane that we did previously, except we are going to change the ending now, because we are consider alkene and alkynes. Therefore, the ending of the system previously that we were learning before is going to ending with "ene" and ending with "I" instead, to specify that there would be double bond and triple bond in the molecule, right? Because alkene contain double bond and alkyne contain triple bond. However, there are a few things that add to this naming system for alkene and alkyne. The first is that when you count the longest continuous carbon chain, the longest continuous carbon chain must include double bond or triple bond. Okay, and then your double bond and triple bond have to be on the lowest number of carbon as well when you do the numbering. Okay, what do I mean by that? Let's take a look at the first example here. Okay, so the first example, we are going to find out the longest continuous chain. Okay, so 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, that's also the same. So therefore, there should be 5 carbon total. And this longest continuous carbon chain contain double bond as well, so that's good. Okay, so now whether we count this as carbon number 1 or count this carbon as number 1, that's when you will need to look at the location of the double bond. The double bond need to be on the carbon at the lowest number position, right? So if I count this as number 1 here, 1, 2, 3, 4, 5, it's going to put the double bond into carbon number 3. Okay, so however, if I count from the other end, 1, 2, 3, 4, 5, it's going to put the double bond on the carbon number 2. So 2 is lower than 3. Therefore, the system that we are going to use, or the longest continuous carbon chain, would be what I label in blue. So this is not correct, right? So I'm going to cross the red out. Therefore, in this case, you are going to do the same thing, right? So we are going to find out what is the attachment, and in this case, attachment is the methyl group. Therefore, you are going to describe the location of methyl group first, so 2-methyl, and you also need to indicate the location of the double bond as well, because according to the isomerism, structural isomer that we learned earlier, these double bond can be at any of those carbon, right? Because there are several structural isomer of this molecule. Therefore, in this case, you will need to specify the location of the double bond. And the location of the double bond would be on the lowest number of carbon. Therefore, it's going to be on the first carbon that is attached. So it would be on the position number 2. So it would be -2. That's to indicate that this is going to be the location of the double bond. And because there are 5 carbons, so the prefix for that would be pent. And because of the double bond, this is the identity of an alkene. Therefore, the ending would be -ene. So the name of this molecule would be 2-methyl 2-pentene. And again, these two describe the double bond in an alkene that have 5 carbons. Okay. Similar to an alkyl, okay, so an alkyl, when after you find out the longest continuous chain, then the next thing is to number and make sure that the triple bond is on the lowest number of carbon. Therefore, in this case, if you count this part right here as number 1, 1, 2, 3, 4, it's going to put the triple bond on carbon number 3. However, if you start on the other side, 1, 2, 3, 4, this one would give the triple bond on the location of carbon number 1. Therefore, the second counting would be the correct one, right? So in this case, since there is no substituent group, you don't have to worry about that. All you need to do is report the location of the triple bond, which is in carbon number 1, that because we have 4 carbon, the prefix for that would be bute, and because of the triple bond is indicate an alkyl, so it would ending with "ine." Okay, so it would be 1-butyl. Now let's take a look at example 2. Okay, so let's take a look at example 2 here. First, we are going to use the same method that we did earlier. We will need to find out the longest chain of hydrocarbon first. Okay, so I'm going to start from here and go all the way here. Okay, so we have 1, 2, 3, 4, 5. If you count these, we will have 5 carbon. Okay, so now if you count 1, 2, 3, 4, you have only 4. If you count 1, 2, 3, 4, that's only 4 as well. But what if I count from here all the way to here, right? So it would be 1, 2, 3, 4, 5, 6. Hey, this is the longest because this one has 6 carbon, but this one has only 5. Therefore, in this case, our longest continuous carbon chain would be this one. Okay. The next part is to make sure as well that your longest continuous carbon chain contain double bond. And yes, it does contain double bond. Okay, so that means this is the correct longest carbon chain. Okay. The next thing is to number. Okay, so to number the carbon. Because because this molecule contains double bond, therefore we will need to base off the double bond first. Okay, so the double bond have to be on the lowest numbering of the carbon. So I'm going to start with this one. So 1, 2, 3, 4, 5, 6. Okay, so and another one that we can do would be 1, 2, 3, 4, 5, 6. Which one is the correct label then? So that's what we are going to take a look based on the double bond. the double bond here, if you count from as the red label, you will see that is going to put the double bond in carbon number 3. Okay, if you use the blue label, you're also going to see that the double bond also on carbon number 3 as well. Therefore, in this case, it doesn't matter whether you count this way or this way, because the double bond will still gonna be in the same location. Okay, same thing for the next group as well, because double bond are on the same location. Therefore, we are going to take a look at the next attachment group. In this case, the methyl group on this one is up here on the the third carbon. Same thing for this system, right? So this methyl group, which is the same as that, also appear on the third carbon as well. Therefore, in this case, doesn't matter which way you are counting, it's going to give you identical name. Okay, so I'm going to go ahead, stick with the first one then, right? The red label, okay, so that way it's easier. Okay, so I'm going to erase this blue one, so that way it's easier for us to see. Okay, so I'm going to circle the group that attach to it. So these are the two groups that attach to the long chain continuous carbon. So because these two contain one carbon, so this is methyl, so these two are methyl group. Therefore, the name of these would describe the number of attachment first, right? So in this case, the location of the attachment is on carbon number 3 and carbon number 4. So it would be 3, 4 dash dimethyl, okay, dash. Okay, so next we are going to, there's no more attachment, so we are going to look at the long chain now. The long chain contains 6 carbon, but there is a double bond, and so we need to specify the location of double bond, which is on the carbon number 3, right? We are going to use the first carbon that the double bond attached to, so it would be carbon number 3, and then dash, and the prefix for 6 long chain carbon would be hex. And because this is an alkene, so it would be hexene. Okay, so that would be the correct name for this molecule. Okay, so the next one, we are going to take a look at the next molecule here on this side. Okay, so first I'm going to find the longest continuous chain. Okay, so if I look at this 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, both of them has same 5 carbons, which is the longest one, because if you count this 1, 2, 3, 4, oh, that's also the longest one too. But note that whenever that you see double bond or triple bond, the longest chain carbon must contain double bond and triple bond. Therefore, in this case, this would not count to be the longest continuous carbon chain, okay, because it doesn't contain triple bond, right? So therefore, in this case, this also not going to consider to be the longest chain as well, because it doesn't contain the triple bond. Therefore, our longest chain would be this one right here, because it includes this triple bond right here. Okay, so 1, 2, 3, 4, 5. Same thing for this, right? 1, 2, 3, 4, 5. Okay, so next, what we are going to take a look at is numbering the carbon. So the number of carbon have to base off the triple bond. So therefore, in this case, we're gonna count from this end 1, 2, 3, 4, 5. Okay, because it's going to put triple bond into the first carbon. Okay, so next you are going to figure out the name of the attachment. In this case, the attachment would be methyl, right? So we have methyl, and we have this group here. If you go back to the table, you will see that this group is the same as this group that is on the table of the alkyl group, okay, which is equal to isopropyl. Which name between methyl and isopropyl should come first? That's when you will need to go by the alphabetically. And we know that I come before M. Therefore, the name of this compound would be 3-isopropyl dash 4-methyl. And since we already described all the attachment, then we are going to look at the long chain hydrocarbon that contain triple bond. So we need to specify the location of the triple bond, which is in the location of carbon number 1. So -1, that's the location of triple bond. followed by the number of long chain carbon, which is 5, that would be pent, and it's contain triple bond, which is an alkyl, so it would be pentyl. Next, let's take a look at naming of cyclic alkane. Okay, so cyclic alkane is similar to naming an alkane. Pretty much you are going to count the number of carbon within the ring, and you are going to start with the word cyclo and ending with ane. For example, this one right here, the number of carbon that we see, right? So 1, 2, 3. Therefore, in this case, the name would be cyclo, right? Because cyclo described that this is the ring structure, and because there are 3 carbons, so that would be pro, and there is no double bond, so it would be type of alkane, so it would be cyclopropane. Okay, so note that the name given here is incorrect, so you need to cross it out. Okay, so the correct one would be cyclopropane here. Now, what if we have substituent group that attach to it? This is the same thing that we did earlier. You just need to numbering the carbon within the cyclic ring first, okay, and then looking at the attachment, right? So in this case, the attachment are on the carbon number 1 and 3, so it would be 1, 3 dash, and these 2 groups are methyl groups, so it would be dimethyl, and followed by cyclo, describe the ring structure, and because there are 4 carbon would be butane. Okay, so now what about this one, right? So the ring structure contains 5 carbon, therefore the ending would be in the ring structure would be cyclopentane, and the substituent group would be ethyl versus methyl, right? So you are going to count the number of this carbon as number 1 because this group right here is ethyl group, E come before M, therefore we are going to count this carbon as number 1 to give the ethyl group as the lowest number than the methyl group, right? So therefore the name would be 1 ethyl, 2 methyl, cyclopentane. The next one is this cyclic ring here. There are 6 carbon, okay, in the ring, and you chloro versus fluoro, C come before F. Therefore, I'm going to give this carbon as carbon number 1, followed by this carbon as number 2 because it contains the second as attachment group. So therefore, the name of this compound would be 1 chloro 2 fluoro cyclohexane. Now let's take a look at example 3. Okay, so same thing here. When you count the number of carbon, you are going to give number 1 to the substituent group, so it would be 1 here, right, to the carbon that have this attachment to it, and then followed by 2, 3, 4, 5, 6. Therefore, the name of this compound would be 1 methyl cyclohexane. Okay. Now the second one here. Okay, so again between chloro and fluoro, C come before F. Therefore, the first carbon would be the one that attached to chlorine, followed by the second attachment carbon, that would be 2, 3, 4, 5. Therefore, the name of this would be 1 dash chloro dash 2 fluoro. Fluoro, and then followed by cyclopentane, right? Because 5 carbon is pent and it's an alkane. Now let's take a look at the next one. Okay, so next one, 1, 2, 3, 4, 5, 6, right? So it doesn't matter which one you count because all of those attachments are the same. So this one I will just give 1, 2, 3, 4, 5, 6, and you will see that carbon number 1, 3, and 5 attached to the same group, which is the methyl group. Therefore, the name would be 1, 3, 5 dash 3 methyl group. You can describe by using prefix tri, right? Tri means 3. So you have 3 of the methyl group, so it would be trimethyl, okay, cyclohexane, because there are 6 carbon in the ring structure. Now let's get into a more challenging problem. What if you see a complex structure like this? how can we apply what we learned earlier from the more simple example, right? So we are going to do the same thing, nothing changed, the process still the same. Whether it's a small structure or a big structure or more complex structure, the system that I teach you is still going to apply the same. Okay, so the first thing is to figure it out the long chain hydrocarbon first, right? The long continuous carbon chain. And because we see the triple bond, therefore that long continuous carbon chains have to include the triple bond as well. Okay, so therefore in this case, I need to include whatever I do to count as a long chain, I need to include this, right? So in this case, it would be 1, 2, 3, 4, 5, 6, 7, 8. So if I do this, right, I would have 8 carbon. If I do it from here to here, it would be 1, 2, 3, 4, 5, 6, 7, 8. It would be the same. And you see that these two kind of like look identical, so it doesn't matter anyway whether you are using this one or this one, right? Is there any other, right? So you can try 1, 2, 3, 4, 5, 6, 7, 8. That's also still 8. So therefore in this case, the longest chain would have 8 carbon. And which way that we are going to count, right? So this is 1 or is this 1? So we are going to count the carbon so that the triple bond would be on the lowest number of carbon. Therefore, I'm going to start with this and this would be number 1. Okay, so 1, 2, 3, 4, 5, 6, 7, 8. I'm going to show you two systems here and you will see that it's going to give you identical answer. Okay, so another one that we can do is 1, 2, 3, 4, 5, 6, 7, 8. You are going to see that you are going to have the same name. Okay, so what do I mean by that? Let's take a look at the first system. Okay, so we know that our longest chain contains 8 carbon. So 8, prefix for 8 would be oct. And because we have triple bond, that would be octi. Therefore, in this case, I know that the ending have to be octi. Which is the same as the blue numbering as well. It have to end with octi because the longest chain contain 8 carbon and it contain the triple bond. And because the triple bond, the first carbon that is attached to is on carbon number 2, so I'm going to write number 2. Right, for the red numbering, same thing for the blue numbering as well. Okay, the next thing I need to worry about is to looking at the attachment group. Okay, so I'm going to use yellow color to indicate the one that I'm consider as the this long chain right here, right, the red one. Okay, so I'm going to circle the attachment group. So this is 1, 2, and we have this one, and we have this whole thing as attachment group, and we have this one as attachment group. Okay, so therefore what you have is methyl, 2 of them. Okay, you have chlorine or chloro, and you have fluoro. Okay, so fluorine change to fluoro, chlorine change to chloro, iodine change to iodo, for example, right? Or bromine, you will need to change to bromo. And this group here is the same as what you see in the alkyl group that written as CH3, CH3, CH3 dash. This group is called third butyl group. Okay, the T or the third part is not going to be counted toward the alphabetically ordering system, right? We are going to ignore this T when we try to find out which alphabet come first. Okay, so now let's take a look at these 4 different groups: butyl, fluoro, chloro, and methyl. Clearly, B come before any of those, so you are going to start with the third butyl first. Therefore, in this case, you are going to start with third butyl. Okay, so I might not have enough space here, so I'm going to write here. So we are going to start with carbon number 6, third butyl. Okay, followed by, okay, so it would be C, right? It would be 5 chloro dash. Okay, so then I'm going to follow down here. Okay, so dash. F come next. It would be 4 fluoro. And 7, 7, because the methyl group are on the same location, right? Dimethyl dash 2 octyl. Now what about if we consider the blue numbering, then would give us the same name? So that's what I'm going to take a look at next. I'm going to go ahead erase this part first, right? Erase the group that we determined earlier. And I'm going to use the green color to indicate the attachment that belong to the blue labels. Okay, so I'm going to use the green. So again, if you consider the blue, the longest chain, right? So these two would be the attachment group, okay? And then this would be another attachment group, right, of the blue. Okay, so we are considered the blue right now. And then this and this. Okay, so still the same, right? So these two group is methyl. This group is fluoro. This group is chloro. This group is tert butyl. Okay. So in order to consider which alphabet come first, again, the tert will not count toward alphabetically order. Therefore, we are going to consider only the B, right? But. So this one would come first. Therefore, in this case, the name would be carbon number 6, right, of the blue labeling that we are considering right now, that the tert butyl attached to. Therefore, the name would be 6 dash tert butyl dash. Okay, so the next one would be chloro, which is C, right? It would be 5 chloro dash. Okay, so the next one would be F, right? Come next would be 4 fluoro, and that followed by the methyl group on the same location, 7, 7, dimethyl, followed by 2 octyl. And you see it doesn't matter which one you use, right? Which way you go, it's gonna give you the same identical answer here. Therefore, the name of this molecule is 6 tert butyl 5 chloro 4 fluoro 7 dimethyl 2 octyl. My expectation for this chapter section is not only for you to look at the structure and give me the name, but you also need to be able to read the name and draw me the structure as well. So let's take a look at example 5. Example 5 gives you the name of the organic compound, and it's asking you to provide a line angle structure. So first, we are going to take a look at the name. Okay, so the easiest way to do this is to look at the ending. The ending is ending with N. This is suggesting you that this is an alkane. Therefore, there is only single bond that within this molecule. And the word non, right, is described that there are 9 carbon. Okay, so in this case, we are going to start with 9 carbon first. And because we want inline structure, so our structure would be a zigzag, right? So it would be 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so total 9 carbon. Then you will need to label this carbon as well, because we are going to attach this substituent group in there. So we are going to label this as 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so that would be ending with no name because this is an alkane. Let's take a look at the attachment group. Okay, so 5-ethyl is indicate that carbon number 5 would contain ethyl group. Ethyl group is this structure here, right? So it's the attachment that contains 2 carbons. So it would be 1, 2, right? So this describes ethyl because it's CH2, CH3. Okay, so that's the ethyl. Now, carbon number 3 and number 6 contain the fluoride group, right? Fluoro come from fluoride. Therefore, you are going to add fluorine into carbon number 3. So there would be fluorine. And also carbon number 6. So we'll add that. Again, note that for the line angle structure, you are omitting carbon and hydrogen But everything else that are not carbon and hydrogen, you will need to include those chemical symbol. Okay, and carbon number 3, we also have the methyl group. Therefore, in this carbon right here, we are going to also include the 3-methyl group. Okay, so methyl group contain 1 carbon. Therefore, you can just leave like that, right? So that describe 1 carbon, right? CH3 group, which is the methyl group. Therefore, the line angle structure would be this structure right here. Okay, for this molecule. Let's take a look at the next one. The next one, same thing. We are going to take a look at the long chain name first, which is cyclohexene. And it's have number 1, 2. The word cyclo indicate that these structure have to be in a cyclic structure or the ring structure. And hex contains 6 carbon. Therefore, we are going to draw 6 carbon cyclic structure. So 1, 2, 3, 4, 5, 6. Right, so I'm going to go ahead label that. Okay, so 1, 2, 3, 4, 5, 6. And it's indicated these contain double bond because ending with "ene." So where are we going to add the double bond? Well, in front, the number in front of it will indicate that, right? You are going to add a double bond in carbon number 1. Okay, so on carbon number 1. Therefore, you are going to add double bond on carbon number 1. Okay, so this one right here, we are going to add double bond right here. Okay, so that's indicate an ene, right? An alkene. Okay, the next thing is you are going to go ahead, start attaching of this substituent group. We know that carbon number 5 has bromine. So carbon number 5 has bromine. Okay, carbon number 3 contain isopropyl. And the structure of isopropyl line structure would be this structure right here. Okay, so CH, CH3, CH3. And 4-methyl, so this would have 4-methyl, it would be that. Okay, so this would be the structure. If you want to write it more beautiful, it would be the same as this structure. I would like you to pause the video and convert this name into the structure. Once you complete, please resume the video again. Now let's take a look at the last name. Okay, the last name ending with I, right? And it's heptide. Therefore, we know that this is going to be the alkyne, right? Because ending with I, with 7 carbon, because hept is it stands for 7 carbon. Therefore, I'm going to go ahead, draw out 7 carbon. So let's start with 1, 2, 3, 4, 5, 6, 7. Okay, so that would be 7 carbon. And we know that this would be heptide. Okay, so that means we need to add triple bond where it's going to be carbon number 1, right? So that one specifies carbon number 1. Therefore, in this case, I'm going to go ahead on carbon number 1. I'm going to add triple bond. So that would be triple bond right there. Right, so it would be carbon number 1, 2, 3, 4, 5, 6, 7. Okay. Then number 4 has third butyl. Therefore, this number 4 right here, the structure of third butyl look like that. Okay. Number 3, there are 2 chlorine attached to it. Okay. And number 5, there is the methyl group. So that would be the structure for this. Note that this triple bond here, this carbon right here has a sp hybridization. Therefore, the structure would not be bent. Okay, it's going to be linear. So the correct picture of this would be 1, 2, that is linear, right? And then attached to carbon number 3, 4, 5, 6, 7. And carbon number 3 contain chlorine, 2 of them. Carbon number 4 has third butyl. Carbon number 5 has methyl. Therefore, the correct structure would be like this.